Well, hi everybody. Good morning. Today we're going to continue with the area between two curves that I introduced the other day. So let's make sure you have your notebooks out or your iPad or whatever it is you're taking notes with. This is a very important topic. We definitely will see this on our AP exam. So we need to make sure that we cover this. Okay, we're looking at the area between the curves. Okay. Now, some of this is already a little bit familiar to you. Okay. So let's just pretend, well, let's just kind of recap what we already know. Okay. So we already know that if we have, why in the world that's doing that? Okay. Wow, what in the world? Okay, so we already know from before if we had a curve like this, right? And we'll just call this point A and this point B, okay? And if we wanted to know the area between the curve and the x-axis, we've been basically saying, we've just been kind of saying, well, let's find the area under the curve, right? That's the phrase that we've been using. But in reality, when we talk about the area under the curve, what we're actually referring to is the area between the curve and the x-axis. Okay, so when we did that, we said, well, let's integrate. Call this f of x. We're going to integrate f of x dx, and that's going to give us the area between the curve and the x-axis. Okay, well, if we threw another curve in there, okay, let's just say we'll call this one g of x, okay? Here's g of x, okay? So, okay. So if we took the area under that curve, we'd get this little piece right here. Right? So if I integrate it from a to b g of x dx, okay, let me see if I can draw that a little cleaner. Once again, I'm using an old computer and it's lagging a bit, so I hope this is going to come out okay. All right, let's try that again. I'm not having success here. Okay, let's try this. We're going to go from here to there. There we go. That's better. There's my g of x, okay? So if I integrate g of x from a to b, I'm getting this area here, the area under that curve. So none of that's new. The new part is, what if I want to know the area between these two? Well, what we're going to do is we're going to take this purple section, I'm making a mess, right? We're going to take that purple section and we're going to subtract out the yellow part, okay? Let me see if I can show you that again, all right? So here's the purple part. If I integrate f of x, I'm getting all of this space here. Well, if I subtract out the yellow space, that's going to leave me with what's in between. So if we want to integrate between the two curves, we're going to integrate from a to b. We're going to take the top curve, f of x, and we're going to subtract the bottom one, which is g of x. Okay, so let's look a little bit more specifically. Okay, when we do this, when we're trying to find the area between the two curves, what we actually have to do first is figure out where they actually intersect. So let's say that this is f of x. Okay, and then let's draw this line. We'll call that g of x. Okay. So first I have to find out where f of x is equal to g of x, because that's going to tell me where they intersect. And I'm going to get, in this case, 2 points. So one point is right here at x equals 0, and let's call this other point, we'll call this 4. Okay, so if I want to find the area between these two curves now, I'm going to integrate from 0 to 4, and I'm going to take the top curve, which is g of x, and I'm going to subtract the one on the bottom, which is f of x, and that will give me the area between the curves. I don't care what else is going on over here. So if I look at this curve, right, this linear function, this is going to continue going, right, and this quadratic is going to continue going, but I don't even care, because the only part that's going to be the area between the curves is right here where they're kind of, there's stuff wedged in there because of their intersecting points. Okay. Sometimes, though, we have to integrate with respect to y instead of with respect to x. So for instance, let's say that I have a curve that looks like this. Let's see here. Maybe I have a curve that looks like this. Okay, and we'll just say that this is over here at 6. Okay, and let's say that we're asked to find the area between the line x equals 0, and we're just going to call this f of x for now, and f of x. Okay, so we're trying to find the area between those two. Then we would integrate with respect to y. So that means instead of looking at the values on the x-axis, we're going to look at the values on the y-axis. So we would go from 0 to 6 on the y-axis. Now this gets a little tricky sometimes, okay? Because if the function is listed as f of x equals something, and we're integrating with respect to y, then we have to do a little bit of work. So for instance, let me see if I can think of an example. Let's say that we have x equals, let's see, negative y squared. That might give us something like that, and say that would be like a minus 6, something like that. Okay, so in this case, notice how this equation is in terms of y instead of in terms of x. Now it might be written as x equals the square or negative square root of y plus 6. Oops, sorry, x, not y. Okay. And if that happens, we have to rearrange it so that it's in this form. And that gets a little bit tricky, okay? So what I'm going to do right now is I'm going to kind of pass you off to the organic chemistry video tutor, and he's going to go through some examples with some, actually some better examples, and talk you through it. When we're finished, you're going to start the assignment if there's time. Okay, you're going to start an assignment in AP Central. There are 2 assignments in there, okay? So one of them you're going to start today, and then you'll finish it. Both of them have to be finished by the end of the day tomorrow. Okay, let me make this clear again. You have 2 assignments, okay? The first assignment that you're going to start is area between the curves in terms of y. okay? The second one is area between the curve. I need to check and see what that's called. Okay, the second one is the area between the curve at more than 2 points. Okay. And in AP Central, it says that they're quizzes. They are not. They're homework. Okay, they're not going to count as quizzes. They are homework, even though it says quiz. Okay, so just remember when you're doing this, think about when you integrate what part of the curve it's actually giving us, right? So if we have a curve that's doing this, right? Call that F, we'll call that G, and if we're looking for the area between them, we need to figure out where they intersect, and then we're going to subtract f of x, because f of x is on top, minus g of x, okay? Okay. The second part of the assignment says if they intersect in more than one place, so you might have something like this. Okay, something like this, all right? We're gonna, here's f of x, and here's g of x, okay? So here, let's say that this is A. From A to B, which curve is on top? F of x is on top, right? So here we would integrate from A to B, and we would do f of x minus g of x. But then, in this next piece here, it switches, and now g of x is on top. So let's call this point C. We would integrate from B to C, but this time it would be g of x minus f of x, okay? So that's what it means by intersecting in more than 2 places. So we have this section here where the f of x function is on the top, so it would be f of x minus g of x. Then we have this section down over here where the g of x is on top, so we have to do it separately, okay? Okay, so I'm going to pass you off to the organic chemistry guy, and he's going to continue going over this.
Let's work on this problem. Calculate the area of the region bounded by the line y equals x and y equals x squared. Y equals x is basically a straight line that passes through the origin at an angle of 45 degrees. So that's y equals x. Y equals x squared is basically a parabola that opens upward but starts at the origin. So if we put those two graphs together, we're going to get something that looks like this. So here's the line y equals x, and here is y equals x squared on the right side. On the left side it just looks like that, but we don't need to worry about it. The area of the region bounded by these two curves is right here. So that's the area that we need to calculate. What we need to do is, we need to determine the points of intersection. We can see the first point is going to be at 0. We got to find the second point. To do that, we want to set these two equal to each other. So we want to set x equal to x squared. Subtracting both sides by x, we'll get that 0 is equal to x squared minus x. And then if we factor out the GCF, if we factor out x, we'll get this expression. Using the zero product property, we can see that x is equal to 0, and x is also equal to 1. So those are the points of intersection. Now the top function is our f of x function, which is y equals x. The bottom function is our g of x function, which is x squared. So now we can calculate the area between the two curves using this formula. It's the definite integral from a to b of the top function f of x minus the bottom function g of x. So this is going to be the integral from 0 to 1. F of x is x, g of x is x squared. The antiderivative of x is going to be x squared over 2. And for x squared, using the power rule, is x to the third over 3. So let's plug in 1. This is going to be 1 squared over 2 minus 1 to the third over 3. And then if we plug in 0, this whole thing will be 0. So it's 1/2 minus 1 over 3. Let's multiply 1/2 by 3 over 3 and 1 over 3 by 2 over 2 to get common denominators. So this becomes 3 over 6. This becomes 2 over 6. And our final answer is 1 over 6. So this is the area between the two curves. It's 1 over 6 square units. Number 3. Calculate the area of the region bounded by the curves y equal x squared and x equal y squared. So let's graph these two functions separately. So this is y is equal to x squared. It's a parabola that opens upward. Now x equals y squared, it opens towards the right. If you take the square root of both sides, you'll get that y is equal to square root of x, plus or minus. The top part of this function is y is equal to positive root x. The bottom part is y is equal to negative square root x. Now if we focus on quadrant 1, where the two curves meet, this is y is equal to x squared, and this is x is equal to y squared. So now this here is the top function, which is f of x, which is basically that function, x is equal to y squared. But solving for y, we know that it's the square root of x is equal to y. And f of x is equal to y. And remember, f of y is equal to x. So be careful, don't get those confused. So we can replace f of x with the stuff that equals y, which is the square root of x. The bottom function is y is equal to x squared. And so that's our g of x function. G of x is also equal to y, just a different type of y. So this is x squared. And our goal is to calculate the area of the shaded region. So first, we need to find the points of intersection. So let's set f of x equal to g of x. So f of x, in terms of x, is the square root of x. G of x is x squared. If we square both sides, we'll get that x is equal to x to the fourth. Now, this is true when x is 0. 0 is equal to 0 to the fourth. And this is true when x is equal to 1. 1 is equal to 1 to the fourth power. So those are the points of intersection. Now that we have that, we can calculate the area using this formula. So the area is going to be the definite integral of a to b, or 0 to 1, of the top function, which is the square root of x. We'll write that as x to the 1/2, minus the bottom function, which is x squared. So the antiderivative of x to the 1/2, we need to add 1 to 1/2, which is 3/2. And then instead of dividing by 3/2, we're going to multiply by the reciprocal, 2/3. The antiderivative of x squared is x cubed over 3. Now let's plug in 1. So this is going to be 2/3 minus 1/3. And when we plug in 0, we'll just get 0. So the final answer is just 1/3. So that's the area between, it's the area of the region bounded by these two curves. So that's the final answer. Now let's move on to number 4. Calculate the area of the region bounded by the curves x is equal to 1 minus y squared and x is equal to y squared minus 1. So first, let's talk about how we can graph this. We know that x is equal to y squared looks like this. If that's x equal y squared, what is x equal y squared minus 1? All we need to do is take this curve and subtract it by 1 along the x-axis. So it's going to move 1 unit to the left. It's going to start at x equals -1. So that's the shape of this graph. It shifted horizontally 1 unit to the left. So now that we have the graph of that function, let's focus on the graph of this function. Now, x equals positive y squared opens to the right. What about x equal negative y squared? What happens then? So this is going to open to the left. It's reflected about the y-axis. Now, what if we add a 1 to it? When we subtract it by 1, the graph started at -1. If we add 1, it's going to start at +1. So x equals negative y squared plus 1. We're going to move 1 unit to the right. So this is the same as x is equal to 1 minus y squared. So what we need to do is combine these two graphs together. So it's going to look something like this. And this is going to be the area of the region bounded by those two curves. So let's redraw that picture. So here we have y squared minus 1. And here we have, actually this was 1 minus y squared. And this one is going to be y squared minus 1. So let me write that. So this is x is equal to y squared minus 1. And this other one here is x is equal to 1 minus y squared. So how can we determine the area of the region bounded by these two curves? Well, we need to find the points of intersection first. So let's set these two expressions equal to each other. And since we have x in terms of y, the points of intersection will be y values. So let's set 1 minus y squared equal to y squared minus 1. So let's add y squared to both sides. And let's add 1 to both sides. So those will cancel. We'll get 2 is equal to 2y squared. Dividing both sides by 2, we get 1 is equal to y squared. And then if we take the square root of both sides, we get 1 is equal to plus or minus 1, which should be written this way. So this is a y value of -1, and this is a y value of +1. So now that we have the y values of the points of intersection, we can calculate the area between the two curves using this formula. It's going to be the integral from c to d, which are y values, of the right function f of y minus the left function g of y. So f of y is here. F of y is 1 minus y squared. We can see it here. It's the function on the right. G of y is the function on the left. This is g of y. It's on the left side for the region that's bounded. So g of y is y squared minus 1. So now we could use this formula. It's going to be the integral from c to d. C is negative 1, d is positive 1. And then f of y, which is 1 minus y squared, minus g of y, which is y squared minus 1 dy. So let's simplify this expression first. This is 1 minus y squared, and then these two negative signs will become positive 1. So 1 plus 1 is 2. Negative y squared minus y squared is negative 2y squared. The antiderivative of 2 is 2y. And for 2y squared, we have 2y to the third over 3, evaluated from negative 1 to 1. So let's plug in 1. This is going to be 2 times 1 minus 2 times 1 to the third over 3. And then if we plug in negative 1, we'll get this. So this becomes 2 minus 2 over 3, and then negative 2 plus 2 over 3. Distributing the negative sign, we'll have plus 2 minus 2 over 3. Now let's combine like terms. 2 plus 2 is 4. Negative 2 over 3 minus 2 over 3, that's negative 4 over 3. So what we need to do now is we need to get common denominators. So 4 over 1, I'm going to multiply that by 3 over 3. So this becomes 12 over 3 minus 4 over 3, which gives me a final answer of 8 over 3. So this here is the area between the two curves. Now let's work on some more practice problems. Calculate the area of the region bounded by the line y equals x squared minus 4x and the x-axis. X squared, we know, opens like this. X squared minus 4x is going to be similar, but it's going to be shifted. So what we need to do is, to graph this, we need to find the x-intercepts and the vertex. So to find the x-intercepts, let's replace y with 0. Let's solve for x. So I'm going to factor out x. Using the zero product property, we get an x-intercept of 0 and of 4. So let's make a table. So when x is 0, y is 0. When x is 4, y is also 0. Now the vertex of a parabola is the midpoint of the x-intercepts. So it's going to be at 2. Another way in which you can get the vertex is by using this equation. X is equal to negative b over 2a. Let's say if you have a quadratic equation, ax squared plus bx plus c. So a is the number in front of x squared, which is 1. B is the number in front of x, which is negative 4. So we have negative b over 2a. So this is positive 4 over 2, which gives us an x value of 2. Now we need to determine the y value. To do that, we can just plug it into this expression. So y is equal to x times x minus 4. If we plug in 2, this is 2 times 2 minus 4. So we get 2 times negative 2, which is negative 4. So we have enough information. Whoops. Let's go back. So we have enough information to graph this function out. So we have an x-intercept of 0 and 4. And at negative 4, we have the vertex at an x value of 2. So the graph is a parabola that opens upward, like this. Our goal is to calculate the area of the region bounded by that line. Well, technically, that should be a curve, not a line. So let's just replace that with the word curve and the x-axis. So how can we find the area of that shaded region? Well, we need to identify the top function and the bottom function. The top function is the x-axis. And that's basically the line y equals 0. So we can say the top function is f of x is equal to 0. The bottom function, g of x, is the curve x squared minus 4x. And we're going to integrate this from 0 to 4. So let's use this formula. It's going to be the integral from a to b of the top function f of x minus the bottom function g of x. So this is going to be the definite integral from 0 to 4. The top function is 0. The bottom function is negative, well, it's minus x squared minus 4x. So let's go ahead and distribute the negative sign. So negative times negative 4x, that's going to be positive 4x, and then minus x squared. The antiderivative of 4x is going to be 4x squared over 2. And for x squared, it's going to be x cubed over 3. So this becomes 2x squared. So we have 2x squared minus x cubed over 3, evaluated from 0 to 4. So let's plug in 4. When we plug in 0, this whole thing is going to be 0. 4 squared is 16 times 2, that's 32. 4 to the third is 64. So we have 64 over 3. Now we need to get common denominators. So let's multiply 32 over 1 by 3 over 3. (32 times 3 is 96. So we have 96 over 3 minus 64 over 3. And 96 minus 64 is 32. So the area of the shaded region is 32 over 3. That's the answer for this problem. Number 6. Calculate the area of the region bounded by the equations y equal x squared minus 4x and y equals 6 minus 3x. So this equation we're familiar with already. We know the x-intercepts will be 0 and 4. And we know that the vertex will be at 2, -4. So this graph is going to open upward like this. So that's a rough sketch. Now here we have a linear equation, y equals 6 minus 3x. So the y-intercept is 6. Which should be somewhere here. And to determine the x-intercept, we can replace y with 0 and solve for x. So adding 3x to both sides, we have 3x is equal to 6. And 6 divided by 3 is 2. So this line is going to touch the x-axis at 2. So that's what we have. And eventually this curve is going to meet up with this line. So our goal is to get the area of the shaded region. What we need to determine is the points of intersection here and here. So we need to calculate the area by taking the top function and subtracting it by the bottom function. So we want the x values of the points of intersection. So let's set these two functions equal to each other. X squared minus 4x, we're going to set that equal to 6 minus 3x. So let's begin by, let's add 3x to both sides. And let's subtract both sides by 6. So on the left side we'll have x squared, negative 4x plus 3x, that's going to be negative x, and then we have negative 6. So we could factor x squared minus x minus 6. Two numbers that multiply to negative 6 but add to the middle coefficient negative 1 are negative 3 and plus 2. So we can write this as x minus 3 times x plus 2. Solving for x, we get that x is equal to positive 3. And if you set x plus 2 equal to 0, you'll get that x is equal to negative 2. So here's the first point of intersection. This is at an x value of 3, and this is at an x value of negative 2. And the top function, that's f of x, which is, it's this linear equation, 6 minus 3x. The bottom function, g of x, is the other one. That's x squared minus 4x. So now let's calculate the area using this formula. So it's going to be the integral from a to b, that is from negative 2 to 3, f of x, which is 6 minus 3x, minus g of x, which is x squared minus 4x. So we have 6. This is negative 3x minus negative 4x, which is negative 3x plus 4x. So that's simply plus x. And then we have negative x squared. Now let's clear away a few things. The antiderivative of 6 is going to be 6x. For x is going to be x squared over 2. And for x squared is going to be x to the third over 3. Evaluated from negative 2 to 3. Now let's plug in 3. So we're going to have 6 times 3 plus 3 squared over 2 minus 3 to the third power over 3. And now let's plug in negative 2. Six times 3 is 18. 3 squared is 9. 3 to the third is 27 divided by 3, that's 9. And then we have negative. 6 times negative 2 is negative 12. Negative 2 squared is 4 divided by 2 is positive 2. Negative 2 to the third power is negative 8. With the negative front, that becomes positive 8, but divided by 3. So here we can combine 18 and negative 9. 18 minus 9 is 9. And here we have negative 12 plus 2, which is negative 10, and then plus 8 over 3. Distributing the negative sign, we have 9 plus 9 over 2, and then we have plus 10 minus 8 over 3. So first, let's combine 9 and 10. So that's just 19. And then let's focus on combining those two fractions. Let's try to get a common denominator of 6. So 19 over 1, I'm going to multiply that by 6 over 6. 9 over 2, I'm going to multiply that by 3 over 3. And 8 over 3, I'm going to multiply that by 2 over 2. "19 times 6 is 114. 9 times 3 is 27. 8 times 2 is 16. "27 minus 16 is 11. And 114 plus 11 is 125. So this is the final answer. This is the area of the shaded region. It's 125 over 6. Number 7. So we want to find the area of the region bounded by these two equations. We got a linear equation and a parabolic equation. Let's begin by graphing the parabolic equation. So we have x equals y squared, which we know is going to open towards the right, but it's going to start at negative 4 along the x-axis. So it's going to look something like this. Now here we have a linear equation. X is equal to 3y minus 2. So when y is 0, x will be negative 2. So that means that the x-intercept is negative 2. Now we have a positive coefficient in front of y. It's positive 3y and not negative 3y. So we know we're going to have a linear equation that's going to increase as x increases. As y increases, x is going to increase, so it's going to go up. So we want to find the area of the shaded region. What we need to do is find the points of intersection first. So let's set 3y minus 2 equal to 2y squared minus 4. So I'm going to take these numbers and move to the other side. So we're going to have 0 is equal to 2y squared. This will be negative 3y on the right side. And then this will be positive 2 on the right. So negative 4 plus positive 2, that's going to be negative 2. So now how can we factor this trinomial where the leading coefficient is 2? To factor it, we need to multiply the leading coefficient by the constant term. 2 times negative 2 is negative 4. And then we need to find two numbers that multiply to negative 4 but add to the middle coefficient, negative 3. this is going to be negative 4 and plus 1. So we're going to replace the middle term, negative 3y, with negative 4y plus 1y. And then we can factor by grouping. So we're going to take out the GCF in the first two terms, and that's 2y. And we'll be left with y minus negative 2. And we're going to take out the GCF in the last two terms, which is just going to be 1, and then times y minus 2. Now these two are the same. So we're going to factor out y minus 2, and we're left with 2y plus 1. So that's how we can factor this trinomial. If we set y minus 2 equal to 0, we'll get y is equal to positive 2. And if we set 2y plus 1 equal to 0, y is going to be negative 1 over 2. So now we have our points of intersection. And these are y values, negative 1/2 and positive 2. So this is equal to C, and this is equal to D, since everything is in terms of y here. So now we could use this formula to get the area. It's going to be the integral from C to D of the function on the right, which is f of y, minus the function on the left, which is g of y. So relative to the shaded region, the function on the right, which is here, that function is f of y, which is the linear equation 3y minus 2. The function on the left, that's the curved function, that's g of y, which has to be the other one, 2y squared minus 4. So the area is going to be from C to D, or from negative 1/2 to 2, f of y, which is 3y minus 2, and then minus g of y, which is 2y squared minus 4 dy. So we have 3y minus 2 minus 2y squared, and then plus 4. So this becomes negative 2y squared plus 3y, and then combining these two, that's going to be plus 2. The antiderivative of negative 2y squared will be negative 2y to the third over 3. For 3y, it's 3y squared over 2. And for 2, it's 2y, evaluated from negative 1/2 to 2. So now, let's plug in 2. This is going to be negative 2 times 2 to the third power over 3, plus 3 times 2 squared over 2, plus 2 times 2. And then let's plug in negative 1/2. So it's negative 2 times negative 1/2 to the third power over 3, plus 3 times negative 1/2 squared over 2, plus 2 times minus 1/2. 2 to the third power is 8 times negative 2, that's negative 16 over 3. 2 squared is 4, divided by 2 is 2 times 3, that gives us 6. And then 2 times 2 is 4. Negative 1/2 to the third power is negative 1 over 8. Negative 1 over 8 times negative 2 is positive 1 over 4. Divided by 3, that becomes positive 1 over 12. Negative 1/2 squared is positive 1/4. Divided by 2, that's 1 over 8. Times 3, that's positive 3 over 8. And then 2 times negative 1/2 is negative 1. So we have negative 16 over 3. 6 plus 4 is 10, distributed in the negative sign, we have negative 1 over 12 minus 3 over 8, and then this is plus 1. So what we need to do is we need to get a common denominator of 3, 12, and 8. The best number is 24. 24 is a multiple of 3, 12, and 8. But first, let's combine 10 and 1, which is 11. We're going to multiply this by 24 over 24. And then negative 16 over 3, we're going to multiply that by 8 over 8. Negative 1 over 12, we'll multiply that by 2 over 2. And negative 3 over 8, we're going to multiply that by 3 over 3 to get a common denominator of 24. So we have 11 times 24, which is 264. 16 times 8 is 128. 2 times 1 is 2. 3 times 3 is 9. So 264 minus 128, that's 136. And negative 2 minus 9 is negative 11. 136 minus 11 is 125. So the answer is 125 over 24 square units. So that is the area of the region bounded by the two curves, or the two equations.
Okay, so he gave you quite a few examples. Okay, so just as a reminder, we're going to say by Monday morning, 8 a.m., right? Due Monday, 8 a.m., you have 2 AP Central assignments. These are not easy assignments, okay? Please take time. You're going to have a quiet space. You're going to have to concentrate. Okay, they're not easy. Everything we're doing right now is difficult, but I know you can do it. You're doing great with your integration. Okay, you just have to think them through and take your time. All right, so you're going to start the first one, and I think I told you the first one is the one that says area between the curves in terms of y. You're going to start that tonight, and then between now and Monday you're going to complete that one, and the other one that says area at more than 2 points. Okay? All right, and I will see you Monday morning. If you have any questions, don't hesitate to shoot me an email. I should be able to respond. All right. See you Monday.